So today my math teacher told me about this very interesting problem, which is the Monty Hall problem. It consists of you having three dots, and behind each dot there is either a good thing or a bad thing. We will represent them as goats, as bad things, yeah, a goat, the animal, and as a present for the good thing. So you can have two doors with goats and one with a present. Which one is which you don't know, so you choose in between one of the three doors and there may be a goat there or a present. What happens that now I will tell you, imagine you chose the first door. Well, I will just remove one of the other ones, one that has a goat in it. So I will remove the one with the goat. Now do you switch your choice? You don't know which is which or which has what, but do you switch your choice? And that's the problem. The solution is yes, you should switch your door, but the thing is, why or how better is it if you switch your door? That's what I'm going to be exploring today. I actually wrote a very janky program in 40 minutes during class, and now I'm going to try and improve it for it to give me results in a format which I can put into Excel and see how all the results compare. So see you in a second for you, an hour for me. Okay, so I think it works now, and I'll let it run overnight, and tomorrow morning we'll see the results. Okay, so it's now tomorrow, but not really morning, since I spent all the day doing stuff. But, well, the point is that now I get to explain you the results of the code, because yes, it's run properly, and now I've got numbers, and I think a theory about why those results exist. But before I can show you the results, you need to understand the code. And don't worry, don't go away, it will be a really fast and simple explanation, please stay with me. Okay, so here we can ignore all of this, it's just complicated stuff. What is really interesting is this, because since I need really big numbers, I get really big numbers by using long, which is pretty funny if you ask me. Then we get to the part of the code that runs as many times as it can. I left it run overnight, so it ran millions or billions of times. We'll look at that afterwards. Okay, so every time this code runs, it just chooses a door to have a price and two doors to not have anything. And then it chooses one of the doors randomly to be its choice. Then it removes one door right here. It just doesn't really remove it, but it tells the computer that, hey, don't bother about this door. And then if I have selected the option to switch the door, it just switches the choice to the other one that is available and that I haven't removed. And well, that's basically it. Then I save the results and that's it. Now we get to the results, which are really interesting. It turns out that if you switch your choice, you have double the chances of winning. Or in other words, if you don't switch your choice, you have a 33.333 period chance of, well, winning. And if you change your choice, you actually double your chances to 66.666 period, basically. Why? Well, that's a very great question, but it's actually really simple. If you have three choices, okay, and one of the three is good, you imagine you choose a bad one. Then every 2 in 3 times you will choose a bad one, but every 1 in 3 you'll choose a good one. What happens? Then, if you have chosen a bad one, I will just remove another bad one and you will switch. So if you have chosen a bad one with a 66.6 period chance of choosing a bad one, that choice will be switched to choosing the good one. So you end up having a 66.6 chance of winning. The same happens the other way around. Imagine you already chose the good one. Well, you will switch, but your chances of choosing the good one on the first step, we'll call it like that, when there are still 3 doors, are 33.3%. So yeah, that's it. I hope you've enjoyed the video. It was really fun to make, and hope to see you in the next video. Bye.